Welcome to our video on key features introduced in Java 17 compared to Java 8. Java has come a long way since its release, with each version bringing new advancements and exciting features. In this video, we will take a closer look at the latest Java 17 release and compare it with the features available in Java 8. So let's dive in. Before we start comparing, let's get a brief overview of Java 8 and its important features. Java 8, released back in 2014, introduced several significant improvements to the language. One of the most notable features was the addition of lambdas and functional interfaces, allowing developers to write more concise and expressive code. Java 8 also brought in the Stream API, which made working with collections more streamlined and efficient. Now, fast forward to Java 17, the latest release. Java 17 presents us with an array of exciting new features to enhance our programming experience. Let's take a look at some of the key advancements in Java 17 compared to Java 8. Local variable type inference, introduced in Java 10, is a feature that allows you to declare local variables without explicitly specifying their types. Instead of explicitly stating the data type of a variable, you can use the var keyword, and Java will infer the type based on the assigned value. This feature simplifies code readability without sacrificing type safety. Here's a basic example of how to use local variable type inference with var. In this example, the type of the message variable is inferred to be string because it is initialized with a string literal. Here are key points and considerations for local variable type inference, var, in Java. Initialization required. You must initialize the variable at the point of declaration when using var. The compiler infers the type based on the assigned value. Type safety. While var simplifies variable declarations, Java is still a statically typed language. The inferred type is known at compile time, ensuring type safety. Immutable versus mutable types. The inferred type depends on the actual type of the value you initialize the variable with. For example, if you initialize it with a mutable object, like a collection, the variable will still be of a reference type. Use cases. Local variable type inference is particularly useful for situations where the type is obvious from the initialization expression, and explicitly specifying the type would be redundant or reduce code readability. It's commonly used for iterating through collections and working with lambda expressions. Not suitable for all cases. While var is a helpful addition to Java, it's not intended to replace explicit type declarations entirely. It should be used judiciously, especially in cases where the type is not immediately obvious or when the type of a variable is essential for readability and understanding the code. Compatibility. Local variable type inference is available in Java 10 and later versions. Code using var can coexist with code written in earlier Java versions, as long as you don't use it for existing method or constructor signatures. TextBlocks, introduced in Java 13 as a preview feature and later made permanent in Java 15, are a new way to represent multi-line strings in Java. They are designed to make it easier to write and maintain strings that span multiple lines while preserving the formatting, including leading and trailing white spaces. Text blocks use triple double quotes to delimit the block and allow you to include line breaks and indentation within the string. Text blocks are particularly useful when dealing with large amounts of textual data, such as SQL queries, HTML templates, or JSON documents. Extended switch expressions. Extended switch expressions were introduced in Java 12 as a preview feature and became a standard feature starting from Java 14. They extend the functionality of the traditional switch statement by allowing it to be used as an expression, which means it can produce a value. With extended switch expressions, you can assign the result of a switch directly to a variable or use it in a return statement. This reduces boilerplate code and makes the switch statement more flexible and concise. Before the introduction of extended switch expressions in Java, switch statements were only used as statements. This means they could not be directly used to produce a value or be part of an expression. Instead, they were primarily used for branching logic based on the value of a variable. With the introduction of extended switch expressions, the same logic can be expressed more concisely and elegantly. In this example, the switch statement is used as an expression, and the result of the expression can be used directly. This makes the code more readable and eliminates the need for temporary variables or repetitive assignments. Extended switch expressions provide a more concise and expressive way to handle branching logic in Java. Pattern matching for instance of. Pattern matching for instance of is a feature introduced in Java 16 that simplifies the common use case of checking the type of an object using the instance of operator and then casting that object to the checked type. It enhances readability, reduces boilerplate code, and mitigates the risk of errors associated with manual casting. Before the introduction of pattern matching for instance of checks were commonly used to determine the type of an object and then cast it to that type. However, this approach often led to repetitive and error-prone code, especially when dealing with nested if-else blocks. With pattern matching for instance of, this code can be rewritten in a more concise and readable way. In this example, the instance of operator is used along with a pattern variable that captures the matched object's value and type. This eliminates the need for explicit casting and provides more concise and readable code, especially in scenarios involving nested instance of checks. Another significant feature introduced after Java 8 is records. Records in Java are a feature introduced in Java 14. They provide a concise and elegant way to define immutable data classes. They streamline the creation of classes whose main purpose is to hold data. Let's dive into an example to see how they work. Consider a scenario where we need to represent a point with x and y coordinates. Traditionally, we create a class with fields, constructors, accessor methods, and other boilerplate code. But with records, this becomes much simpler. Here, we've declared a point record with two components x and y. The record keyword automatically generates the constructor, accessor methods for x and y, equals, hashcode, and toString methods. The code using records becomes much more concise and readable. With just one line of code, we've defined a data class that represents a point with x and y coordinates. In this usage example, we create a new point object named point with the x coordinate as 5 and the y coordinate as 7. We then use the accessor methods x and y to retrieve the values of the x and y coordinates, respectively. Records promote immutability by making their components immutable after initialization. Once a point record is created, its x and y values cannot be modified, ensuring data integrity. Records simplify the creation and usage of immutable data classes, making code more expressive and maintainable. Sealed classes. Sealed classes are another notable addition to Java, introduced in Java 15. They provide a way to restrict which classes can extend or implement a given class or interface. Sealed classes enable developers to define a closed set of subclasses or implementations, enhancing code maintainability and robustness. To declare a sealed class or interface, use the sealed modifier followed by the class or interface declaration. Then, specify the permitted subclasses or implementations using the permits keyword. Consider a scenario where we have a sealed class shape representing geometric shapes. Shape is a sealed class permitting circle, rectangle, and triangle as its subclasses. Sealed classes ensure that only the permitted subclasses can extend or implement them. This helps in preventing unexpected extensions or implementations that could compromise the integrity of the code base. Only circle, rectangle, and triangle are allowed to extend the shape class. Here are some additional notes on sealed classes. Modifiers for subclasses. Subclasses of a sealed class must be declared with one of the following modifiers: sealed, non-sealed, or final. Restriction on inheritance. Sealed classes do not allow other classes to extend them directly. They must explicitly declare and define all permitted subclasses. Explicit declaration of children. The sealed class must declare and specify all its permitted subclasses using the permits keyword. This declaration ensures that the hierarchy remains well-defined and controlled. Java modules. Before Java 9, the Java Runtime Environment, JRE, was a crucial part of the Java Development Kit, JDK. However, with the introduction of Java 9 and the Java Platform Module System, significant changes occurred. The JRE was modularized into multiple smaller modules, now residing in the JMods folder. This restructuring adds another layer of abstraction above packages, akin to a package of packages. There are some advantages of Java modules. Encapsulation. Modules helps prevent unwanted access to internal APIs and implementation details, improving code maintainability, and reducing the risk of errors caused by unintended interactions. Suppose we have a module named com_example.database that encapsulates database-related functionality. By specifying which packages are exported, only designated parts of the module's functionality are accessible to other modules, maintaining encapsulation. Dependency management. Modules explicitly declare their dependencies on other modules, making it easier to manage dependencies and understand the relationships between different components of an application. This helps reduce class path issues and makes it easier to identify and resolve dependency conflicts. In a modular application, if Module A requires functionality from Module B, Module A explicitly declares its dependency on Module B in its moduleinfo.java file. This ensures that Module B is present at compile time and runtime, enabling seamless integration. Improved security. Java modules provide stronger encapsulation, effectively hiding internal APIs and implementation details. This reduces the risk of unauthorized access and potential security vulnerabilities. Performance optimization. Modularization enhances application startup time and reduces memory footprint by loading only the necessary modules and classes at runtime. Simplified deployment. Modules facilitate the packaging and deployment of Java applications by offering a clear structure and minimizing the likelihood of dependency conflicts. When deploying a modular application, developers can package modules independently, ensuring that each module contains its dependencies. This simplifies deployment processes and reduces the risk of version conflicts between different components of the application. This video provides an overview of Java 17 compared to Java 8, offering insights into the key features and improvements introduced in recent Java versions. While it doesn't delve into the detailed implementation of each feature, it gives you a comprehensive look at the advancements made in Java development. If you found the video helpful and informative, please consider giving it a thumbs up and subscribing to the channel for more in-depth discussions on technology. By subscribing, you'll stay notified about new videos, ensuring you don't miss out on valuable insights and updates in the tech world. Click the notification button to stay updated. Thank you for watching and being a part of our community of technology enthusiasts.